So here we'll look at the different types of evaporators, and we'll look at the advantages and disadvantages of each one. So in a batch type pan evaporator, you have obviously dahil batch type siya. So pagsalang mo ng liquid, ipaprocess mo siya for a certain time and then poof, lalabas yung concentrate mo. It can be done in open atmosphere or vacuum. Vacuum hastens the process by lowering the boiling point of water. But you have to apply a vacuum or something na hihigop ng hangin from that closed setup using pumps. The heat transfer rate is low because you only use natural convection. So pag kumulo yung product mo, yun lang paggalaw ng molecule sa loob ng product as a result of boiling or heating up yung nagkakos ng heat transfer within the product mismo. Okay, so you have here a natural circulation evaporator, continuous configuration using a closed setup para may vacuum pressure ka. Advantages are fast heat transfer rate, although you use natural convection still. So paikot-ikot lang dito yung product mo habang nagko-concentrate siya. Alright, so you have a steam jacketed vessel here, and then the inner tubes there sa loob, nandun dumadalo yung mga fluid pataas. And as they are heated with steam, so pagdating nila sa areang ito, mag-vaporize, mag-evaporate rather yung product, yung water from the product, and then leading to a more concentrated product na output. Ito naman is a rising film evaporator dahil yung feed mo nang gagaling sa ilalim, and then paakyat po siya through those small narrow tubes similar to the previous one, and then as it rises it's being heated with steam, and again as pagpasok niya dito magse-separate yung nag-water vapor hihigupin, and then the concentrated product goes out. Therefore it's a continuous process. Although the limitation is for low viscosity food because it won't be able to rise kung masyado siyang malapot at nadikit sa walls ng pipes mo. So in the falling film evaporator, the difference naman is yun lang, pinagbaliktad mo lang yung inlet nasa taas and then babagsak siya by gravity towards the product output area, okay? And obviously siya ay for more viscous and sensitive food. So dahil at least pag viscous bababa pa rin siya, no? And as it goes down, doon nangyayari yung heat transfer. Nagsa-start mag-evaporate. Hihigupin lang lahat ng water vapor ulit. So by the way, for you to have an idea about how these equipment look like in real life, you can just Google them. No? Hindi na kasya sa slides masyado at dadami rin yung pictures. And here we have the rising falling film evaporator. So it has a very quick heat transfer rate, and parang mo lang literally kinambine yung dalawa. So the feeds at the bottom, as it rises, you use the steam to heat it up. And then as it falls, pagdating dun sa kabilang side, niinit mo pa rin siya. And then as it comes out to this area, you suck out all the water vapor and the denser concentrated product comes out. Okay, here we have the forced circulation from the name, forced circulation evaporator. From the name, it implies na meron kang external force na ginagamit to circulate, which in this case is provided by a circulating pump that converts electricity into mechanical force to drive your fluid around. Okay? So, ganun pa rin, meron kang main na heat exchange chamber dito kung saan may steam ka and all that. And then, paakit siya dito. So, notice in this part, it has to be filled with liquid to prevent boiling while in this area sa pipe. Pero once it enters the more open area and may headspace ka dyan, magve-vaporize bigla yung iyong very hot liquid, and they can collect the water vapor immediately. Then there's an outlet for the concentrated liquid. However, if you wish to do so, you can keep circulating the liquid. Okay, in the agitated thin film evaporator, so para siyang falling film pero meron kang higanting agitator. So this one is a giant paddle, if you can see the cross section. Okay, so habang nahuhulog yung feed dyan and it comes into contact with may heat transfer na nagaganap through the steam dyan sa jacket niya. So ini-steer mo to increase the rate of heat transfer within the fluid. Especially for high viscosity food na medyo alam naman natin, di ba, from your FS 127 na kapag mas taas ang viscosity, mas mabagal ang heat transfer within the material. But generally, it's still conduction, no? Kasi conduction from the pipe to the fluid, and since highly viscous siya, mas conductive than convective yung heat transfer doon sa fluid mo mismo. So we've learned in the past module how to do yung ating mass balance, and then we know how to use steam tables basically, and then we also have a general idea of how to do energy balance. So now we'll combine all those things in trying to solve evaporator problems. So single effect lang tayo kasi medyo mahirap na yung double and triple effects, and as a proof of concept lang naman tayo para ma-practice yung utak natin sa paggamit ng energy balance. So actually, pwede na naman i-derive from scratch yung mga ito, but generally there's a formula to it, no? Pero kaya to ng common sense kahit hindi ka mag-review, basta naintindihan mo yung konsepto ng mass and energy balance. So we take note first of all that the mass of steam does not change because it is not in direct contact with your product. So the mass of steam in is equal to its mass out. It only transfers energy in the process that it condenses, but nothing else happens to its mass unless may leak ka. Or you have a type of evaporator that mukha siyang steamer, no? Indirect contact yung steam sa product, but that's very rare. So we'll use the following notations: F for the feed, V for the vapor, P for the product, and S for steam. Vapor refers to the product that is evaporated from the feed, or the fraction of the product evaporated from the feed. No? So overall mass balance niya, the mass of your feed equals the mass of the vapor plus the mass of, the product. Alright, and then the mass fraction of the, let's say, solids, halimbawa, in the feed multiplied by the mass flow rate of the feed is equal to the mass fraction of solids in the product multiplied by the mass flow rate of the product, since tie component nga natin dito yung parang solids component niya. Okay, for the energy balance, so simple lang naman, yung mass na binigay ng steam, yung energy na binigay ng steam as it condenses from its steam form into its condensate form is equal to the mass that is absorbed by your water vapor and your product, less the mass of the energy in your feed. So in short, the energy of all your inputs, which is your steam and your feed, should equal the energy of all your output streams, assuming steady state tayo na walang accumulation ng energy or heat dito sa loob ng equipment natin. So paano natin ilalagay yun? Ayan, no? So makikita nyo dito, mass flow rate of feed multiplied by the specific heat of your feed plus the mass flow rate of your steam multiplied by the enthalpy of your steam at its current condition sa pag-input, temperature and pressure, equals the mass flow rate of your vapor multiplied by the enthalpy of your vapor plus the mass flow rate of your product multiplied by the enthalpy of your product, and then the mass flow rate of the steam multiplied by the enthalpy of the condensed steam, or CS. So, saan natin gagamitin yung steam table values dyan? Dito. Okay. dito, and dito. So yung values ng enthalpy ng steam sa input, condensate sa output, and then yung sa vapor. Note, sabi natin, di ba, we use steam tables kung tubig ang pinag-uusapan. And then, since yung feed at product ay hindi naman pure water, they could be anything from juices to tomato paste or what. So gagamit na lang tayo ng calculated specific heat values or predetermined specific heat values. So dito magiging useful yung mga equations natin on yung mga MC delta T. So in heat, mass and energy balance, specifically for evaporators, there is what we call the overall heat transfer coefficient, or U, in watts per area per unit temperature, or watts per square meter Kelvin. So what this means based on the units, diba, is the rate of heat transfer for each square meter of surface area ng loob ng inyong chamber, and for each Kelvin na difference ng temperature. Okay? So anyway, so the heat transfer then is given by U multiplied by the area and the delta T to get a value in watts. And this is equated to the mass flow rate of steam multiplied by the difference in the enthalpies of the steam input and output pag nag-condense yung steam. Okay, so yung CS, ito yon, no? This is supposed to be CS. And technically, the U value is a function not simply of the equipment, but also of the product concentration. But we won't be using this much though. So let's try a sample problem. You have apple juice concentrated in a natural circulation single effect evaporator at steady state. So these are necessary assumptions. And the dilute juice is fed at a rate of 0.67 kilograms per second. And the concentration is 11% total solids. Juice concentrated to 75% total solids, and specific heats are given for the dilute and concentrated apple juice. Now the steam pressure is also given, as well as the inlet feed temperature, and the product inside the evaporator boils at a certain temperature as well. So take note na dahil naka-vacuum siya, mas mababa yung boiling point than the typical 100 degrees Celsius or so. And you are also given the U value or heat transfer coefficient at 943 watts per meter squared degree Celsius or Kelvin. And here it's important that we assume negligible boiling point elevation, because otherwise the problem would need probably derivatives to solve, no? So pinasimplify na actually to, and we are to find the mass flow rate of the concentrated product, steam requirement, steam economy, and the heat transfer area.
So how do we even start solving this problem? Well, the first step is to not panic. Don't panic, okay? Andyan na yung mga given ninyo, lista nyo muna lahat, and then here are some tips pala, no? So first, you are to assume na saturated instead of superheated yung steam, kasi kung mapapansin nyo, for the steam, only the pressure was given and not the temperature. So unless binigay yung temp, hindi mo malalaman kung superheated ba siya o hindi. So we assume na hindi. And then the steam condenses into saturated liquid, therefore mag-phase change lang siya pero walang temperature change. Kung ano yung temp ng steam, yun din yung temp ng condensed liquid. Kaya makikita nyo dun sa sample diagram a few slides back, TS and TS yung input and output temp ng steam. Okay, so again, after you list all the givens and list all the things you need to solve, you write down all the pertinent equations. So this is like mass balance, only a bit harder, no? Okay, so yung common sense would go a long way in trying to analyze problems like this. Anyway, in this case naman na drawing na yung process flow diagram for us, tapos andyan na rin yung mga variables, inlets and outlets, no? So we have, of course, the givens, mass flow rate of the feed, then the proportions of solids in the feed and product respectively. This will be used as your tie component, solids, and then you have the steam pressure. So you will use the steam pressure to derive the steam's temperature and therefore get the values ng enthalpy of saturated vapor and saturated liquid from your steam table. You might need to interpolate to get the temperature. Um, then you have the temperature of the feed and the product. So, goes without saying yung temperature ng product at yung temperature ng vapor from the product is the same. So, you will use this for your MC delta T's. Okay. And then the U. So, may equation with the U so that you can get other unknowns to help you solve the problem. And then the specific heat for the feed and specific heat for the product will be used to aid in solving the energy balance natin. Right, so we are to solve for the following. So ilan lang yung sinabi actually, no, para mga mass of steam, steam economy, and heat transfer area. But the underlying problem is to be able to solve for those things. You also need to get the mass of the or mass flow rate of the product, mass flow rate of the vapor. Yung mass net ay yung combined mass nito syempre equal sa mass flow rate ng feed natin. And then you need to get the enthalpy values for the feed, for the product, as well as the enthalpy values for the saturated vapor, condensed vapor, and the vapor that evaporated from the product. Okay, and after you get the following, you'll be able to solve these by plugging the equations and setting the unknown on one side of the equation. Right, so here are the answers to the problem. So you would know kung tama yung nagawa ninyo. Again, you solve it more or less in the order na pinakita ko yung mga things to solve for sa previous slide. And you can use the equations for single effect evaporator in the earlier slides to try and solve them one by one. The key here is to use the steam table. Okay, first to interpolate the steam temperature, then from there makukuha nyo through interpolating again for each one itong value na ito. Okay, and itong value na ito. Right, so kung makikita nyo yan, yung kung ma-interpolate nyo yung steam temperature from the steam table, you can also interpolate the enthalpy values and use this as inputs for your equations, and pretty much everything is just plugged into the equations. Okay, for a double and triple effect evaporator, so makikita nyo medyo mas complicated, no, yung mass and energy balance niya. And this is trickier to solve, but I'll just leave this here to show you na hindi na pala tayo pinahirapan ni Sir. Pero pwede nyo namang aralin to. The concepts are the same, just the math is a little bit more messy dahil ang dami mong equations sabay-sabay tinitingnan. And nalilito ka na sa dami ng subscript ng variables mo. But it's generally the same process. And here's just a sample problem for you to solve if you want to, but I'm not requiring you. And most of you will likely not try to attempt this even, no? Except for mastery purposes.